Hello, and welcome to today's problem, 79 daily temperatures. So, you're given an array of integers temperatures which represents the daily temperatures, and you want to return an array answer such that answer at that index is the number of days that you have to wait after the ith day in order to get a warmer temperature. If there's no future day for which this is possible, you want to return 0 instead. So let's start off first by taking a look at the examples. We have the temperatures array over here, and we have the output 11421100. So with this, let's take a look. The reason why the output is 1 at here is because the next warmest value at that index, the 0th index, is 1, because the difference is 73 and 74. The difference between the next warmest one is 1. Same thing with 74. We can go ahead and take a look what the next warmest one is. That's 75. Difference is 1. For 75, the next warmest one is 76, which is a distance of 4 over here. So yeah, so that's why the values are like this, so on and so forth. A quick way to solve this would be by having two pointers, one at the current index that you're on, and the other traversing forward until you find one at the next warmest. What you can do is subtract the indexes of both the second pointer and the first pointer in order to figure out what the value should be at that given index. We can add that to the results array, and then we can turn that as the final answer. The problem with this, though, is that it's O of n squared, and it won't be really efficient for large datasets because you're going to have to loop again for every single element as the dataset expands. So what we can use instead is something called a monotonically decreasing stack. So the best way for me to explain this would be using the example over here. Let's say we want to figure out what that final result is from this array over here. What we can do is we can have a monostack. We can initialize it here, and then we can add the first value, 73 over here, along with the index that it's currently at. So we have 73 and 0 over here. Now, as we go forward for the next value, the nature of what a monotonically decreasing stack is to make sure that every single value in the array decreases as you go towards the basically as you keep adding elements. So in our situation here, if we try to add 74, so 74 at index 1, it wouldn't be a monotonically decreasing stack because it's a greater element. And since we're trying to find the warmest temperature of, let's say like the index at like index 0 for the value 73, we know that 74 is a greater value, and since this is added to the stack and it doesn't fulfill the properties of the monotonically decreasing stack, what we can do is remove this item, so 73 and 0 from the stack, we remove it, we pop it from the stack, and we add to that results array, so we can have a results array over here, which you can then add the difference between this index, 1, and the index of the value we just popped, which is basically 0. So 1 minus 0, it's 1. We can add that to the results array. And this basically fulfills the constraints behind the monotonically decreasing stack. So we have 74 and 1. We can keep going on forward with this. We add 75 at 2. Because we know this is greater, we can pop this 74 value and figure out what that value is by subtracting the indexes between what we just added, 2, and that value, like the value of at that index, which is 1. So we can have that one value here. We can pop that element from the stack as well, and 75 will be the new element in the mono stack. So we'll go ahead and do this again. Let's say like we have like 71. We add this to the stack. We take a look at the index 0, 1, 2, 3, and because it's less than the elements currently in the monostack, the last element of the monostack, we can just keep this and keep moving forward because it doesn't fulfill the what we need in order to get in order to add into the results array, which is a warmer temperature. So we'll go ahead and keep doing this. We hit 69. We know that since it's less, we'll have that value also in the stack as well, and then we hit 72 at the temperature, or like at the index 5. So 0, 1, 2, 3, 4, 5. We go ahead and see this, and we notice that for the values, basically 69 over here, we notice that it's greater that is greater than 69. So we'll go ahead and pop that element from the stack. So we add, for 69, we add that element, like basically like at 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. We add basically the difference between there and there into the stack, which is 1, and then we keep moving on forward. So we'll pop that element from the stack. Well, also with this one, we notice the same thing. If the difference is 2, so we figure out what the difference is in between those values. We pop that element from the stack, and now this fulfills the constraints of it always being decreasing, and we keep moving on forward and forward and forward until this results array is fully populated. And at the very end, if the elements are still in the stack, we can return that final answer 0 at the very end. In this way, we don't have to traverse through the array basically twice. We can traverse through it once and keep adding to the monostack and adding to the results array as we pop elements from the stack, because it doesn't fulfill the constraints of the monotonically decreasing stack. So yeah, if that makes sense, I'll go ahead and begin coding up the implementation now. The first thing we need to do is to create the results array. So res equals 0, and we need that to be as long as the length of the temperatures array itself. So we want to populate it with just 0 at all those ones, so we can modify it as we see fit. So temperatures, yeah. So the next thing we need is the monostack itself. So we'll initialize that here, monostack, and what we can have is a comment saying we want first the value, so the temperature, and then you want the index as the second value. Now, basically what we can do now is we can loop through all the temperatures, keeping track of the temperature and the index. So for index temperature in temperatures, we want to check to see while the stack is valid, while the elements in the stack, and we want to see whether or not the current temperature that we're traversing through is greater than the latest element in the stack, which should be the the least warmest one. And we want to check to see basically the temperature of that one. If that's valid, what we want to do is we want to pop, so stack index, stack temperature, stack index. We want to pop that from the stack, from the monostack dot pop, and from there what we can do is we can add to the results array, basically results at that stack index. We want to add the difference between the current the current element, or the current index of what we're traversing through, and what the stack's index is, like we were talking about before. We want to subtract those two values apart in order to figure out the difference between them. And at the very end of that, what we can do is we can append the current element to the stack, so the process can repeat over and over again. So I guess monostack dot appends, and we want to append the temperature and then the index. And at the very end, we can go ahead and return the result. So yeah, just to walk through it again with another example to verify, what we have 30, 40, 50, 60. Within the monostack, we traverse through the first element, 30. We add that to the monostack, so 30 and 0. And then we move on to the next one. We hit 40, 40 and 0, or 40 at index 1. We go ahead and do this. We notice this is larger, so while the stack exists, it does exist, and while the temperature is greater than the last element in that monostack, like the top element in the stack pretty much, the temperature of it, we notice that it's greater. So what we do is we pop this element from the stack, and then we add the difference between 1 and 0 to the results array, and basically have that as the final value. And then after that, we'll go ahead and append this value to keep continuing the process at the very end. And if nothing happens at the very end, like if this value is still in the stack, what's going to happen is it'll default to 0, because that's what the original array is populated with. So if we go ahead and run this now, oh right, sorry, well, the monostack is existing. Right. Okay, let me go ahead and take a look at the stack index. Yep, mono stack. Any other areas where I've made typos? I don't think so. Alright, accepted all test cases. And yeah, this one is better time complexity because you're only really iterating through the temperatures array once. The space complexity in the worst case would be O of n because you're going to have to populate that monotonically decreasing stack as you go along. So yeah, thank you for watching.